Okay, gang, I'm going to make a little video of solving some problems for the Unit 1 celebration. So this is today's date, 8/21/15, Friday night. So here we go. So the first one, you probably remember, if you want to figure out how much it costs for one computer, it's going to be $4,800 divided by however many computers there are, so that would be 4,800 divided by C. If you want to write an algebraic expression, then this would be, let's see, the product of 4 and a number, so that would be, that's the product, it's multiplication, and it's 7 fewer than that, so 4x minus 7. Simplify, this is the order of operations, and so what you want to do there is parentheses first, so we're going to go 4, we're going to go 13 minus 6, which is 7, plus, and then I'm going to go ahead and keep the 10 divided by 2. Next would be multiplication and division, so we'd want to do this, so that would be 28 plus, and we want to do the 10 divided by 2, so that's going to be 5. Add those together, 33. Another order of operations, so we want to do, it's 165 minus, we're going to do inside the parentheses, so it'll be 3 plus 4 squared is 16. So that's the first step, and then we still are working within the parentheses, so we're going to go 3 plus, we're going to have to do the 16 times the 2, which is 32, minus 8. We're still within the parentheses, so then we're going to go 185 minus, and this will be 35 minus 8, so that will be what, 35 minus 8, so 27. And then we can finally add those two together, and that would be 138. So that's order of operations. We're going to do a little bit here with rational and irrational numbers. So which one is irrational? That would be the radical 11, because it's not a perfect square. So make a little note here, because it's not a perfect square. Okay. And then which one of these is rational? The one that actually you can take the square root of, so 121 equals 11, so this is the one that's rational. These others aren't perfect squares, these first two here. And then 3.46 dot dot dot, it's really unclear as to whether that pattern continues. You would have to have a bar over something for you to know that the pattern continues. Which word best describes the sum? Remember, a sum is adding, so you can't really add those two together anyways, so this would be irrational. We would still have the radical 7 and radical 11. It just would be like this, and there's nothing we can really do. The product would be multiplying, so radical 7 times radical 11 is radical 77, or square root of 77. And that's not a perfect square either, so that's irrational. The product of radical 3 and 12, so that's again multiplication. So radical 3 times radical 12 is radical 36, which is a perfect square, so that's 6. So this turns out to be rational. Which one of these is not a rational number? Well, it's kind of kind of a trick question because this ends up being D, none of the above, because all of these turn out to be rational. So none of the above. So I'm going to explain a little bit there. So if I was to figure out the product of 2 and 0.3 with a bar over it, it would actually be 2 times 1/3. That's what 0.3 with a bar over it is equivalent to. So that would be 2/3. That would be fine. And then when I add these two together, the radicals cancel out. So that would be a positive radical and a minus radical cancel out, and that would be equal to 7, and that would be great because of the 2 plus 5. And then the product of these two fractions multiplied straight across, that would be 3 over 14, and of course that's rational as well. So none of those are irrational. Alright, this one, it rained lightly for a while, poured heavily, and then moderately for a while before finally ending. Which one represents the situation? Well, since it's total rainfall, the total rainfall never really will go down. It'll just keep accumulating. So C is the only one that makes sense. Let's see. Jennifer deposited a sum of money into her account and then deposited equal amounts for 5 months, then resume. So sketch a reasonable graph of the account history. So let's see. She deposited a sum of money, so as time went on, she deposited, sorry about that. She deposited a sum of money, so and then that money, that would stay the same, that same amount of money would stay the same, and then let's see what would happen, equal amounts for 5 months, so then after a month it would be up here, and then the next month it would be up here, so it'd actually go up every 5 months, and then it would be the same. And actually, let me back that up, make the graph a little bit better. So let me label this a little bit more. So let's see, this would be 1 month, 2 months, 3 months, 4 months, 5 months. So each of the months she would be depositing, so that it would be going up. And then this would be at 5 months. It says she does nothing for 3 months, so that means the money would stay the same. And then what happens? Then she resumes equal monthly deposits, so then it would keep going up and up and up. Kind of makes sense. It'd be kind of like a step function there, actually. Sorry, somebody's texting me. Okay, so now some conversions. So let's make sure we're good at these. So we start off, we have 20 kilometers per hour. And then we leave ourselves lots of space, and we want to change it into meters per minute. Okay, so we say equals. Okay, we're going to figure out, we need to go from hours all the way to minutes, and so we're going to convert. The conversion there would be 1 hour is the same thing as 60 minutes. So the hours would cancel out. Then we're going to need to, so we're good on minutes. Then we need to change the kilometers to meters. So we're going to put 1 kilometer on the bottom, and we're going to put 1,000 meters on the top. And that's strategic because the kilometers need to cancel out. And now we can multiply straight across. So when we multiply straight across, we get 20,000 meters over, looks like 60 minutes. And then we can go ahead and do that division. And that turns out to be equal to, sorry I ran out of room there. That turns out to be 333 0.3, and that's meters per minute. Meters per minute. Okay, so sorry, that's a little messy there, but we just divide those numbers. 20,000 over 60. Okay, let's see, this one here, we have a train that travels 120 miles in 1 hour. So 120 miles in 1 hour. And then we put the goal off to the right. So that would be, it looks like we want to go miles per minute. And we need to figure out how to just do one conversion here. So we want to change the hours into minutes. So we're going to go 1 hour is the same thing as 60 minutes. So the hours will cancel out. We'll multiply straight across. So we'll have 120 miles over 60 minutes. And those divide nicely. And so we'll have a just nice even 2 miles per minute. Simplify. So this is our FOIL process. So we're going to go first times first. And then we're going to, so let's go ahead and do that. So first times first, so that would be 25. Then we're going to do the outer. So that's 5 times a negative radical 7. Which is minus 5 radical 7. Then we're going to do the inside, which is positive 5 radical 7. And then we're going to do the last times the last, which is minus radical 7 times minus radical 7, which is minus 7. The two middle terms cancel out, so that would be 25 minus 7. Which is 18. And then what we want to do here is describe the product of radical 5 and 13. So that would be them multiplied together. So that would be square root of 15. And that's irrational because that's not a perfect square. So I think the rest of these is pretty much repetitive. So radical 3, the product, radical 3 times radical 3 is equal to 3, and that's rational. So I think we're in good shape. Good luck.